Assalamualaikum. We are from Group 2 and our topic is evaporation, infiltration, stream flow and groundwater measurement. So my name is Nurul Fatim Fatiha and this is my group member Yashwini, IP Guganasi, CUB and Ziki. Introductions. Hydrology is the science that encompasses the accurate distribution management of water on Earth and their relationship with the environment within each piece of the hydrologic circle. So this project is to study about evaporations, infiltration, stream flow and groundwater measurement. Each of it are split on how evaporation, infiltration, stream flow and groundwater measure are made with. Objective. The first one is to explore how the process of evaporation changes liquid into the gas, and the second one is to explore the subsurface conditions under earth, the soil, and the third one is to state the factors that influencing evaporation, precipitation, stream flow, infiltrations, groundwater flow, and the other. To identify the types and characteristics of the soil based on infiltration rate of the water in the soil. And the last point is to determine the infiltration rate of water into the soil in the particular area.
Study area. Evaporation measurement using mass transfer technique. The energy budget and mass transfer methods are currently being used to measure evaporation from lakes and reservoirs. Because the field equipment is expensive and data processing and analysis are time consuming, the use of the energy budget method is limited to those reservoirs where the need for detailed information warrants the expenses. Infiltration measurement using double ring infiltrometer. Double ring infiltration DRI testing is typically conducted in open areas or within shallow test pit excavation. DRI testing utilizes concentric outer and inner rings that are forced or driven into the soil at shallow depths. The rings are filled with water to test the infiltration rate of the soil at a particular location and depth. The outer ring is to prevent or limit the water from the inner ring from flowing laterally. Stream flow measurement. While streams and rivers may be monitored for many qualities and parameters that they share with lakes, ponds and basins, they possess one quality that sets them apart from other freshwater bodies' movement. Stream flow is a keystone parameter that impacts many other aspects of rivers' hydrology and water quality. Although these other aspects may be just vital to a river's health or just as applicable to a particular project. Groundwater velocity by using Darcy's law. Groundwater is water that fills pores and fractures in the ground. The top of groundwater is called the water table. Between the water table and the land surface is the unsaturated zone. In the unsaturated zone, moisture is moving downward to the water table to recharge the groundwater. The water table can be very close to the surface, within a few feet, or very deep, up to several hundred feet.
I'm Yashwini Ratna with metric number CF190055. And now I'm going to explain about the evaporation rate on meteorology part. And now let's see about the evaporation. Evaporation is known as a method used to separate the homogeneous mixtures which contain dissolved salts. It is takeover when substance become gas. Normally, heating enables the mixture to drive off the liquid components until no more liquid remain. And then the molecules play its roles by moving and vibrating all around. The molecules then moves into atmosphere as water vapor molecules. There are some factors that affecting the evaporation, which are air pressure, temperature, and humidity as well. There are some methods too to calculate the evaporation rate, such as the use of bands, the water budget, the energy budget, and also mass transfer. In this research, we used mass transfer technique to obtain the evaporation rate by using the data from an article.
Infiltration. Infiltration is the process by which water percolates into the soil near the surface. The water on the ground can come from rain, snowmelt, and anthropogenic activity. The infiltration capacity of a soil is defined as the maximum rate of water absorption that a soil can achieve under any given condition. There are several factors affecting infiltration, which is precipitation, soil characteristic, soil moisture content, organic material in soil, land cover, and slope. Various methods exist to determine the volume or rate of water infiltration into a soil. The most frequently used method of determining the rate of infiltration is through a field test using a cylinder or ring infiltrometer. Normally, the ring is driven approximately 5 cm into the ground. Water is applied inside using a constant head device, and intake measurements are taken until a constant rate of infiltration is achieved.
Stream flow can define as the quantity of water flowing in a stream, or it known as stream flow discharge. The discharge is expressed in terms of volume per meter time passes at any given point in a stream, and the SI unit is cubic meter per second. Stream flow provides several important information which help related agencies able to execute a well-planned in water supply and flood planning and warning. Factor affecting runoff. First, type of precipitation. Basically, it can be compared by using rainfall and snow. If the precipitation in form of snow, they will flow to the ground surface after they melt. Therefore, the melted water infiltrates into the soil and little amount of surface runoff. Next, duration of rainfall. If the duration of rainfall longer, then the amount of rainfall will be greater. Lastly, physiographic factors include the size, depth, shape, and slope of watershed. One of the simple ways to estimate stream flow discharge is using velocity area method. The measurement of velocity using current meter are more accurate. It can be measured at double reading and single reading. After that, calculation will be conducted using mid or mean section. Calculation. The cross-section of the stream is divided with equally width, and mean section method is selected for calculation. Solution. First, we need to find the average velocity. Next, width of each section. Third, area, and lastly, discharge. To make the calculation more easier, we construct it in table form. And finally, we found that 9.23 is our total discharge.
Groundwater velocity measurement by using Darcy's law. Description methods. Groundwater science is complex and many different types of information are required for a complete understanding. The most important piece of information, however, is hydraulic head, which is simply the elevation of the water surface in a well relative to a specified elevation datum such as sea level. When head is combined with basic geologic properties like hydraulic conductivity, much about groundwater flow direction can be deduced, and this is a good starting point for investigating all types of groundwater situations. Fundamentals of Darcy's law, hydraulic head, hydraulic gradient, and potentiometric contours are presented conceptually and visually, transforming institution into knowledge with minimal mathematics. What is Darcy's law? The principle that governs how fluid moves in the subsurface is called Darcy's law. Darcy's law is an equation that defines the ability of a fluid to flow through a porous media such as rock. It relies on the fact that the amount of flow between 2 points is directly related to the difference in pressure between the points, the distance between the points, and the interconnectivity of flows pathways in the rock between the points. The measurement of interconnectivity is called permeability. Modern format, using a particular sign convention, Darcy's law is usually written as Q equals to KADH over DL, where Q equals to rate of water flow, volume per time, K equals to hydraulic conductivity, A is column cross-sectional area, DH over DL is hydraulic gradient, that is the change in head over the length of interest. When calculating the possibility of fluid flow from a hydraulically fractured zone to a freshwater zone, the application of Darcy's law is critical because it sets out the specific conditions under which fluid could flow from one zone to another and will ultimately determine whether or not hydraulic fracturing fluids can reach a freshwater zone.
And here we have concluded that we have learned the process that emerging on precipitation cycle, which are evaporation, infiltration, stream flow, and groundwater measurements as well. And the objectives were successfully achieved, and we are able to find out the concept of each measurement with their condition and also limitations. And the calculations of the process are more clear and understand to analyze at last. Thank you.